Okay, this is the module quiz review for Module 2. We are on page 41. And since we've been practicing these skills for a while, it might be best to try all these problems to the best of your ability and then resume this video when you are ready to check your answers. All right, we're going to go ahead and start with numbers 1 through 4. I'm going to go ahead and make a little whiteboard here so we can show some work. And the questions read, find the GCF, which is greatest common factor, for each pair of numbers. So what I can do for number 1 here is I can simply list the two numbers 20 and 32. And if I list all the factors, I can figure out the greatest common factor. Of course, the factors of 20 start at 1, 2 is a factor of 20, 4, and it's going to be 4 times 5. And so now I can just find the partners. It's going to be 2 times 10, and it's going to be 1 times 20. So now I want to think about, of those, which of those would be in 32? And I think the answer is going to be 4. It's going to be 1 and 2, and 3 is not a factor of 32, but 4 is. And it's going to be 4 times 8. It's going to be 2 times 16, and it's going to be 1 times 32. And I think I got all those. And if I carefully examine my list, I'm going to notice that 4 is the greatest factor in both lists. So the greatest common factor of 20 and 32 is 4. All right, so let's check out number 2. Go ahead and make my whiteboard a little bit longer here. I don't know if I'll need to, but... All right, so the factors of 24 and 56. I'm going to show you a little shortcut on this one. So I'm just going to do the factors of 24 because we've done these so many times and they're pretty easy, in fact. So I'm going to do 1, and it's going to be 2, 3, it's going to be 4 times 6. It would be 3 times 8, and 2 times 12, and 1 times 24. I kind of have those memorized because we've done the factors of 24 quite a few times. Now what I'm going to do is not do the factors of 56, and here's why. Since I'm looking for the, I'm going to go up to my directions here. Since I'm looking for the greatest common factor, that means it's the greatest number that's in both lists. Could the answer be 24? And so my question is 24 a factor of 56? So if I counted by 24, I'd go 24, 48, and then it would go above 56. So it can't be 24. Could it be 12? Is 12 a factor of 56? 12 times 4 is 48. No, it can't be 12. What about 8? Does 8 go into 56? And it does. I know that 7 and 8, 7 times 8. Now, I don't actually need to know the rest of my numbers here, and I don't even need to know these numbers here, because I know that 8's going to be the greatest one in both lists. So that's a little trick on how to go kind of fast on these. I'm going to apply that same trick on numbers 3 and 4 as well. So check this out. The factors of 36 and 90. Factors of 36 include 1, 2, 3, 4, 6, and it's 6 times 6. Now I'm just going to kind of work backwards and find partners. It's going to be 4 times 9. It's going to be 3 times 12. It's going to be 2 times 18. And it's going to be 1 times 36. Just like last time, what I'm going to do is I'm going to start at the end here, and I'm going to ask myself, is 36 a factor of 90? 36 doesn't go evenly into 90. Does 18? Well, there's only really one way to find out. I guess you could use a calculator, but you simply needed to divide 18 into 90. And does 18 go into 90? And I could guess and check and maybe say 4 or 5. Maybe I'll just try a 5. What's 18 times 5? Well, as a math teacher, I of course know that 18 times 5 is 90. 5 times 4 is, or 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9, it's 90. I know that 18 goes into 36, and I now know that 18 goes into 90. 18 is a factor of 90, so it would be the greatest common factor. I bet a lot of kids put 9 on there, but they just probably didn't know that 18 was actually a factor of 90. And for time's sake, I think we're just going to go quickly on number 4. 15 is a factor of both 45 and 75. It's the greatest number that goes into both. So go ahead and check those 4. If you got any wrong, please fix them. And let's move on. Okay, number 5 is still a greatest common factor problem. And I know that because, look, it's under the greatest common factor section there. And there's also a word in there that helps us figure that out. Number 5 reads, 28 girls and 32 boys volunteer to plant trees at a school. The principal divides the girls and boys into identical groups that have girls and boys in each group. What is the greatest number? What is the greatest number? That tells you it's a GCF problem right there. When you're taking your test and you see those words, you now know it's a GCF problem. What is the greatest number of groups the principal can make? Well, this is a GCF problem, so I'm simply going to find the factors of 28 and 32, and I'm going to try and find the greatest common factor of both lists. And I'll just do the factors of 28, and then I'll think about which ones would be in 32. 1 and 2 and 4. It's going to be 4 times 7. It's going to be 2 times 14. And it's going to be 1 times 28. And that's all the factors of 28. And then which of those would be factors of 32? Is 28 a factor of 32? No. Is 14 a factor of 32? No. Is 7? No. But 4 is. In fact, I can show you. The factors of 32 are 1 and 2 and 4 and 8. Well, I can stop right there because I already know that whatever these big numbers are, they're not going to be in the factors of 28 list. So the answer is 4. So it's not just 4 though, because the question doesn't say just identify the greatest common factor. It says what is the greatest number of groups the principal can make. The principal can make 4 groups. So when you're given a word problem, make sure you answer using at least a word. Okay? All right, let us move on. The next section is these kind of tricky problems right here. It says, write the sum of the numbers as the product of their GCF and another sum. So I want to review with you kind of how to do this. Notice it says GCF. First thing you need to do when you do these problems right here is to find the GCF. So the GCF of 32 and 20 is, this one's pretty simple if you just kind of review your facts. The greatest common factor of 32 and 20 is 4. So what we do is we write equal, and we pull out our GCF. And so 4 is going to be equal to, and then that gets multiplied by, and then we need to define the two partners. And here's what I mean by that. How many times does 4 go into 32? It's 8. So my first term here is 8. And here's how we can check. What is 4 times 8? Well, it's 32. Now I ignore the 8 for a minute, and I think about my second number, and I just ask myself the same question I asked myself earlier. How many times does 4 go into 20? And that's 5. So now I can do 4 times 5. What is 4 times 5? It's 20. So now I'm feeling pretty good about this. And it says write the sum of the numbers as the product of their GCF and another sum. Well, the sum would be 13. So I can just simply write 4 times 13. And you can check your answer too by simply going like this. I'm going to add up 32 plus 20. And I get 52. Now I'm going to do 4 times 13. And as long as it's 52, then I feel pretty good that I got it right. So let's do the same thing for number 7. First things first is we're going to copy down the problem, and then we're going to identify the greatest common factor. And this is a simple one. These are both multiples of 9, so I'm going to say 9 is the greatest common factor. And then I've got to come up with the two numbers. How many times does 9 go into the first number? 9 goes into 18 twice. 9 goes into 27 3 times. I put an addition sign between those, and I've got 9 times 2 plus 3. Well, 2 plus 3 is 5, so I'm going to write 9 times 5. And again, I'm going to check my answer like I did before. I know my facts. 9 times 5 is 45. Now I just need to check. 18 plus 27 is 45. Okay, well, I feel pretty good about those answers then. All right, let's move on. We're now in the least common multiple section of this review. And the first problem, the first set of directions reads, find the LCM of each pair of numbers. So you just need to keep clear, we were just reviewing greatest common factors. That means to list factors. Well, when we now go LCM, we list multiples. And so if I list the multiples of 6 and 12, the multiples of 6 go 6 and 12 and 18. And I could keep going forever, multiples never end, but I might want to check the multiples of 12 so I don't go too far. The multiples of 12, well, the first multiple of every number is itself, so 12 times 1 is 12, and I'm all of a sudden done. Bam. 12 is the LCM of those two numbers. And this reviews with us the LCM when there's two numbers and it's an LCM problem and one of them is a multiple of the other, then the LCM is actually the larger number. It's really pretty simple. Now that's not going to work for 9 because 6 and 10 are not multiples of each other. We still don't have to go very far on 6 and 10. The multiples of 6 are 6, 12, 18, 24, and 30, and something tells me I should stop because I know that the multiples of 10 are 10 and 20 and 30, and I'm done. All right, the multiples of 8 and 9. And this one takes a while, unless you know your facts really well. Maybe you just know your facts really well and you know the answer. But the multiples of 8 and 9 are 8, 16, 24, 32, 40, 48, 56, 64, 72. Something tells me that's the answer because I know that 8 times 9 is 72. If you do your multiples of 9, you get 9, 18, 27, 36, 45, 54, 63, and 72. Sometimes the LCM is when you multiply the two numbers together. Now, have you caught on yet when that is? It's when they don't share a factor. Since 8 and 9 don't share a factor, then their LCM is actually when you multiply those two numbers together. If you were to ask me, well, go back to number 9, Mr. Smith. How come the answer is not 60? Well, because 6 and 10 share a factor of 2, so it's not going to be 60. It's going to be less than 60. It's actually 60 divided by 2, which is 30. All right, last one. On number 11, that one isn't going to be 9 times 12 because 9 and 12 share a factor of 3. So if you list out the multiples of 9, you get 9, 18, 36. I'm sorry, 27, 36. And if you list the multiples of 12, you get 12, 24, 36. And that's our answer. 36 is the LCM of 9 and 12. All right. If Juanita runs every third day and swims every fifth day, Juanita runs every third day and swims every fifth day. If Juanita runs and swims today, in how many days will she run and swim again on the same day? Well, like we just stated, since 3 and 5 don't share a factor, their LCM is just 3 times 5, which is 15. It's going to be 15 days from now. All right, let's check out the last question. What types of problems can be solved using the greatest common factor, and what types of problems can be solved using the least common multiple? So they use, here's basically the notes I want you to take on this. When the problem states what is the greatest number of ... that's going to be, it will be a GCF problem. When the problem states what is the least or fewest number of ... it will be an LCM problem. That's just the notes I want you to take, because when we get to the assessment in the word problems, that's basically what it will be. You can review that exact concept on this very page. Okay, you are done with page 41. Good job.